In understanding class members, we want to start by reviewing from a point of knowledge. Earlier on, in a previous session, we had discussed that class members include fields, constructors, and methods. I keep saying we've discussed because I'm really hoping this was an interactive session. Anyway, I had walked us through fields, constructors, and methods. In fields, we have two types, instance variable and class variable. So far before now, we just call them fields. But moving forward, we will learn how to differentiate between instance variable and class variable. So with instance variable, every instance you create of your class or the blueprint, rather every object that you create from a class will have a distinct copies in different memory locations of the fields. So these are what we call instance variables, and we can see this in different instances of the circle class. Let me just remind us about the circle class. Here's the circle class. It has two fields. It has the field origin 1. It has the field origin 2. Every instance you create of this circle will then have two distinct field copies of two distinct copies of the fields in different memory locations. So they are called instance variables because they every instance of the class will have distinct copies of the said variables. With class variables, they are stored in one memory location, and every instance shares that same class variable from the one memory location. So we have the static keyword appended to it. We work with the static keyword to make it a class variable or a static field. So as you're seeing in this example, this object would access it and from the same memory location, and so with this one. This is why it's best to consider working with them when you want to do things like track the number of circles that were created from it. And I'll show us an example. So any object can change its value and it can be manipulated without going through the instance. You can just call the class name and the class variable. So let's go and see the difference between the two. So this is the class variable. We need to use the word static. So the modifier, static keyword, data type, then the name of the variable, and I'm initializing it to 0. Why am I doing this? I want to show us the instances where you would need to work with a class variable. For example, when you want to track the number of objects that were created from this, or rather the number of objects that were created from the circle blueprint. In this case, in my initialization, in my constructor, so this is my constructor here, I would initialize the field origin 1 to what arguments will be passed. I will initialize origin 2 to whatever arguments will be passed. Then I'll increment this static variable. If I do that, what I expect to happen is anytime I create an object, it will increment the singular memory location. So it will continuously increment, and that record will be kept as the class variable. To demonstrate that, in my main method here, I'll start by printing the number of circles. So I expect this to be 0 because it's in that one memory location. What has been stored is 0. Then I'll initialize, I'll create an object or an instance of the class circle by the name oval. And then I'll print again. I expect that to be 1 because in my initialization, I'm incrementing the number of circles. Then I'll print and I'll create another object, and then I'll print that just to make sure that it is a 2. So let's run that first. Here we go. So we have 0 as expected, 1 as expected, 2 as expected. If I was to continue on to print other objects, it will do the same thing. It is going to the same memory location and initializing it and changing it at that point. So the latest one, the latest value applies. This next 2 here is from this line here. So it's also possible to access the class variable through an object like I have right now. Via the object round, I need to access number of circles. If I do that, it will give me the latest value of that object. And as it stands, it's still 2 because I have not created another instance or another object from that class. So take your time with this to fully understand what a class variable is. It stores things in a singular memory location. So if at all you make any changes, it tracks those changes from a singular memory location. Let's see if we can prove that. I'll change this to an instance variable to test that out. And in that case, it will need me to access it via an object. So I'll just comment out every error I see first. So I can demonstrate. So it needs me to access it via an object since it's an instance variable. I cannot access it outside. What will happen here? If I run this, it's giving me 1, 1. Why? Every instance had a single separate or distinct copy of the fields. So that means when it was initialized, the first time it was a 1, and the second time with a different object initialization, it was also incremented by 1, and nothing was stored. So just to repeat that again, if you want to have an instance in your code where you are tracking a field value from one memory location, then you need to work with a class variable. So I've just returned it back to the way it was, a class variable. Again, it's possible to still access a class variable from the object, or from the instance, but it is not preferred because it will be hard for someone to determine directly that this is a static variable. Unlike in this case, if you understand the rules of Java, you will instantly know this is a static variable or a class variable because I'm accessing it by the class name only, not by the instance. Okay. So there we go. This is a visual representation of that every instance shares that variable. This is why it was possible to increment, to see the latest increment of the said variable. Another thing we have is class methods. So class methods similarly have the static keyword. We've seen this in the main method, and they can access class variables and class methods directly. So if you have your class variable or static fields, your class methods or static methods from within the same class, they would be accessible directly in a static method. However, the limitations of class methods is you cannot access instance variables or instance methods directly because, I mean, it's not an instance. So what are you trying to access? If you want to access an instance variable, you will need to create an object reference, then access it via the object reference. I'll demonstrate this. Another thing you cannot do is to work with this keyword. This is referring to the instance of that class or that object particularly. So given that it's a class variable, there's no instance that exists that you can refer to, and that is why it is as it is. So let me just demonstrate this. So I have this class variable here, public static int get number of circles, and because I know it can access class variables, then it's possible for me to return this class variable from within that method. So it's an int, it's expecting a return value of type int, and I'm returning number of circles. That's possible. What is not possible is for me to return origin 1. In fact, it errors, like it gives me a red as if I've made up the name. There's no such variable in my code. It doesn't know how to recognize this variable name, although for I do have that variable as an instance variable. So it's not possible for me to access from within a class method a field or an instance variable. So I'll just comment this out and show us how you can access it instead. If you want to access a class variable, you will need to access it via its object. And earlier on, when we were discussing objects, I showed us how it's possible to just append the value, the field, next to the reference that has been returned. So we have new circle 22, which is our instantiation of our constructor, and initialization in 1 actually. So it's returning the reference, and then from the reference we are accessing origin 1, and it's an integer, and we're saving that in an integer. This is possible. So I'll just comment that out. Again, you can practice with this. I'll have the link to the code. This is a visual representation of how you would access the the instance variable from the static method or class method. It's what I've just demonstrated. You'll need an object reference to access them, because as you've seen, there are different memory locations, and in fact there's no instance here, so it's really not apparent what instance it's referring to. But this is an oversimplification, really. I'm just trying to make it easier for us to understand what's going on in the background. So we have the class name and the class method still as a means of accessing it. Then we have the constants. So with constants, you just add final to the static variable. So it is a constant, meaning that the value cannot be changed. And normally in Java or conventionally, we use upper case when naming constants. This is an example of a constant, pi, for the mathematicians in the house. So we have static final. We need the static and final, both static and final here. Then you assign a value to it. If I attempt to give it a different value, for example here, to reassign it, if I attempt to reassign it here, it will error out because this is a constant, it cannot be reassigned. So it's a compile time error there. Just so you know, this is be treated as a constant. You need to work with static final and continue on with the declaration as we saw for variables. So yeah, that is it with constants. Okay, so see you on the next one.